Right, so this video is about continuous random variables, and in particular about probability density functions. So firstly we need to consider what is a continuous random variable. And a continuous random variable could be something like time, or it could be something like length, where you can have like in-between values. These are continuous random variables, and that's as opposed to discrete random variables, which would be the number of times something happens. So, for example, the number of sixes that you throw when you roll a dice 10 times. That would be an example of that. You can't throw 3.5 sixes. But a continuous variable can take any of the in-between values. So time and length would be examples of a continuous random variable. So let's look at this probability density function, which shows the heights of a number of people. So you can see that there are two broad groups here. There's a group of smaller people and a group of much taller people. And you can see that there's very few people of this height, between about 160 centimetres. And you can see that the tall people all have approximately the same height, whereas the smaller people in this group have their heights more randomly distributed. So what are the key things to know about a probability density function? Well, here are the three key points that you need to know. Firstly, it's the area under the curve that tells you the probability. So the probability that x is between a and b is the area under the curve between a and b. So if we've got a probability density function like that, we want to know what's the probability that the variable is between a and b. It's the area that tells us the probability. Secondly, the probability density cannot be negative, so it never goes below the horizontal axis. And thirdly, because the area represents the probability and the total probability is 1, the total area under the curve must be 1. So these are the three key things that you need to know about. So here's an example, and we've got a probability density function which is defined in two sections. Between 1 and 4 it's got this equation, and outside 1 and 4, smaller than 1 and bigger than 4, it's 0. So what does this function look like? Well, it's basically like a x squared plus 1 multiplied by k. That's between 1 and 4. But otherwise, it's 0. So the probability density function looks a little bit like that. And it's important to remember to put these bits in. So we're asked to find the value of k for which it's a valid probability density function. Well, it's a valid function if the area under the curve equals 1. So how do we find the area? Well, we need to use some integration. So we know that this area here is 1. So what we know is that the integral of kx squared plus 1 between 1 and 4, the total area is 1. So we need to integrate. If we integrate, well, let's firstly take the k out as a factor. Integrate x squared, that's 1/3 x cubed. Integrate 1, that's x. It's between 1 and 4, so that equals 1. So therefore we get 4 cubed plus 4 minus 1 cubed minus 1. Be careful to make sure you remember to put that as a minus. This works out to be 24, so therefore 24k equals 1, therefore k is 1 over 24. The next question asks us to find the probability that x equals 3. Now, it's areas that represent probabilities, so what we're after is the area of that line. Doesn't make any sense, it's a trick question. You wouldn't get this in an A-level exam, but for the purposes of reminding you how these probability works, I've asked you to consider this. So the probability that x equals 3 is 0. You can't have an area of a line. But you may have the probability that x is between 2 and 3. So between 2 and 3, what we need to find out is that area there. So the probability that x is between 2 and 3 is the integral of the function. We know that k is 1/24th, x squared plus 1 dx. So I can take out the 1/24th like I did before, and to integrate x squared, that's x cubed over 3, and to integrate 1, that's x, and it's between 2 and 3. So it's 1/24th, 3 cubed is 27, divided by 3 is 9, 2 cubed is 8, minus 2, remember that minus sign, and this works out to be 11/36. So that's part B answered. This was part A. And then part C asks you the probability that x is between 2 and 3, but this time it can equal 2. Over here it couldn't equal 2, over here it can equal 2. And this is another trick question. It's another question that you wouldn't get in your A-level exam. That's obviously just the same, because the probability that x equals 2, which is the only difference, is 0. So the difference between this and this is that here we've got to add on the extra bit where x equals 2, but the probability that x equals 2 is 0. So if you add on 0 to 11/36, then you get 11/36. So that's that question completed. Now we've got this question to look at, and between 0 and 3 the function is 1/6 x, and between 3 and 4 it's 2 minus a half x. Now we can check that we've got this right. Let's put in 3 into here. 1/6 of 3 is a half. So this point here is 3, and that height is a half. And then let's just check here. Let's put 3 into this one. 2 minus a half of 3. Half of 3 is 1.5. 2 minus 1.5 is a half. So that point here is 3.5. Let's put in x equals 4. 2 minus a half of 4. Half of 4 is 2. 2 minus 2 is 0. Yes, that point there is 4, 0. And obviously this point here is 0, 0. So they want the probability that x is between 2 and 4. So they're after us finding out this total area here, where that value there is 2. Now to do this, we need to do this in 2 sections. So the probability that x is between 2 and 4, firstly, it's this area here, that's the red area, and then it's also this area here, which is the blue area. So the red area is the integral between 2 and 3 of 1/6 x, and then the blue area is the area between 3 and 4 of 2 minus a half x. Oops, I forgot the dx. So that's there. So you need to do this in 2 sections. You can't just do this in 1 section. So let's integrate 1/6 x. That's 1/12 x squared between 2 and 3. And then let's integrate 2 minus a half x, so that's 2x minus a quarter x squared between 3 and 4. So that's 3 squared over 12, that's 9/12, that's 3/4, minus 2 squared over 12, that's 1/3, and then it's 8 minus 4 squared is 16, 16 divided by 4 is 4, minus, and then put in 3, so that's 6 minus a quarter of 9, so that's that bit there. So when you work all this out completely, it works out to be 2/3.